Well, good afternoon, everyone, and welcome to this AI versus traditional programming mini class. My name is Amr. I handle the technical courses here at the AstroLabs Academy. I just wanted to give you small details before we start, and then I'll kind of introduce you to Salman, the instructor for today. So basically, the reason we are having recently many sessions regarding data science and data analysis is because we saw the current trend in the market about data and the concentration on data in many fields. So basically, there are currently more than 80,000 data-related jobs in the GCC alone. The average salary for for a data scientist is more than 30,000 dirhams a month, and I guess the most importantly and the biggest number here is that there was a 25% growth in data science jobs in Dubai in 2020 only. So you can see, because of the whole pandemic that happened and moving to working from home and all this kind of stuff, has really put so much concentration in data science. Now, us as Astrolabs, what we're trying to help with that is part of our goal in building the technical ecosystem here in the region. We do provide courses related to that aspect. So as you can see here, we have the data science and machine learning bootcamp happening in May. We're currently running a batch at this month, and we have another one happening in May. This course to handle everything from the basics of Python up to advanced machine learning, which is one of our vision to help you get into this field. You can scan the QR code if you want to know more details. And also we have another course, which is the intro to coding, where we start with the basics of coding, HTML, CSS, JavaScript, computer science fundamentals, what is coding, and all those kind of stuff, because we believe that in the future, those skills are going to be more of a requirement, not just a luxury. If you want, you can check the details. You can also you can see my email and my WhatsApp number. You can feel free to reach out for me if you have any more questions. And without further ado, I'll leave you to Salman, who will be the instructor for today.
Oh, hello everyone. Um, just okay. So my name is Salman. I'm a software developer. Also, I'm part of training programming in AstroLab, especially the data science and the AI program. So I just want to know that everyone am I audible to everyone? Just type something in the chat like. Everything is you
Yeah,
can
guys, feel free to send us on the chat. Feel free to interact
yeah.
with us, ask questions, give feedback. Let's have a discussion.
I just want to no, yeah, I mean, okay, fine.
No worries,
So
Mohammed. You can use the chat. You can use the mic. It's fine. It's up to you.
yeah, so just we how many people we are having right now? Just Amit, are you there? Hi, just send hi. If you are there, you can just type in hi in the chat. That's it. Muhammad Sharif, Warren. Yeah, hi Amit. So yeah, I think you guys can hear me now. So all right. So, as Amar mentioned about, okay, okay, fine. So as Amar mentioned about this course, Astrolab is doing a lot of training program, and this is part of one such program. And so this especially is a mini course, and I'm just going to cover a small topic, especially very beginner introduction kind of level of topic in this session, and we will be having more in the coming weeks. And today's session, especially, I've decided to start with the difference between AI programming and the traditional programming. So why someone want to use uh, uh, AI programming above the traditional programming? That's the topic of today's session. So I'm just going to share my screen so you guys can see my presentation. Yeah. I think just one. I'm looking for this chat session as well. So when okay, so all right. So we will start from this. What make it different from AI from the traditional programming? So um, the traditional programming, it's usually rule based system, which means it's always you need to know the rules before start programming. Like you have your own rules, and you make these rules as an algorithm, and you use your data. So then you write your traditional programming, a normal, like I mean the traditional programming means any languages like Python, JavaScript, C++, anything. So you write your programming in your preferred language, and you will get a output. So which means you have an input, and you have some algorithms, and you have your output. So um, so this is the basic building block of a traditional programming. So, and for example, I can just show this. So this is an activity recognition problem, which means just you want to write a program to know whether a person is just walking, running, or is cycling, or is doing something else. So in a traditional programming approach, what you do is you write your own rules. Like let's say if the speed, you measure the speed of this person, and if you say, yeah. So whenever you want to feel want to ask something, just feel free to unmute your mic and just ask during the session itself. Okay. So in this traditional approach, what you do is you make your own rules. Like let's say for this, if the speed is less than 4, you can say the person is walking. And if the speed is less than 4, and the status is walking or the status is running, you can make your own rules like this. So here, if the speed is less than 4, it's walking. If speed is less than 12, it's running, or else it will be biking. So you need to know all the possible things. I mean possible changes or possible parameters maybe in your program. So based on that, you make your own algorithms, and you make your own programs. And then you can just, here is, let's say here the input of this program will be the speed, and you can just give the input as speed, and you will get the output as the status. And in this case it will be the walking, and in this case it will be if it's less than 4, it's walking, or otherwise it's running. So in this case, it's walking, running, or biking. So this is the traditional approach of programming. And what makes it different from AI programming? So in AI or machine learning, so machine learning is a subset of this AI, artificial intelligence. So whenever I'm saying machine learning, it's also artificial intelligence. So I think you guys can just relate that. So in machine learning, what really happened is that you have some answers, and you have some data, and you will create some machine learning models, and what you will get is the rules. So when you look at here, you already have the rules, and you have the data, and you are getting the answers. But in this case, in AI approach, you don't know the rules. You know the answers of some of your, I mean, you have a data which contain a some answers. So I'll explain this more in the next coming session, so you will understand what it is exactly. So this is the basic, concept differentiation from machine learning or AI with the traditional programming. So yeah, so you can just compare. It's in here. You have rules already. You know the rules in the traditional programming, but you don't know the rules. Your output will be the rules in the machine learning approach. And here your input is just some data and answers, and this is your machine learning model, and you will get output as the rules. So how yeah, so this is just a flow chart diagram, just mentioning about the same thing. I'm just repeating the same with the by using this flow chart, so you will get more about this. So in this tradition, this is about the traditional approach. So in the traditional approach, what you have is you have a problem, and you study the problem, and you write the rules for that problem, and then you evaluate that problem. And if something is not working, you analyze, and then just go back and repeat this. Then finally you launch. So this is the flowchart of a traditional approach. And in the machine learning approach, you have used uh, still there is a problem because we are solving some problem. And there is a model, so we are training this machine learning uh, model algorithm, and then evaluate the solution and analyze the errors and study the problem. But this part, it's mostly done by the machine itself. So along with, while you train the algorithm, you're using the data for training the algorithm and then launch. So which means yeah, this is the machine learning approach, the same I discussed with the previous slide. So in here, hello. uh, okay, uh, so I can explain this concept with real numbers or just a real world example. So it's a kind of uh, uh, guessing game. So there are some inputs. This is just two inputs and outputs. And when you give input as 0, you will get 32 as output, and 8 you will give 46, and when you give 15 you will get 59, so and so. So it's kind of an exercise for you guys. I just want to ask, what will be the output of 32? Any guess? Any guess? Anyone can just answer. Hello. Actually, I can't
Sorry,
see this.
can you repeat the question, please?
Yeah, sure. So we have, yeah, cool. So we have two set of numbers. One is input numbers and one is an output numbers. So when you give, this is, just forget about this machine learning and everything. Just look at this, and if you give input, you have a number 0, and this is something related to this number. Its value is 32, and you have a number 8, and you will get an output 46. So you have 15 and you will get an output 59. So I'm just asking, what will be the number if, yeah, someone, Amit is type something. So you have 38, what will be the output? So anyone else want to answer this? Just type any number, it's fine. So you can guess, and you can just, okay. So the Amit, you're right. The answer is 38. So how it became 38? So one way is, if you don't know about this, just we can guess, like, by just relating these two numbers, and we can just purely guess what will be this number. But this input and output is not just any random input and output. This actually uh, numbers get from equation like this. So this is a simple Fahrenheit to Celsius conversion equation. So you have so the input we given here are this Celsius, and the output is the Fahrenheit. So here we have um, input and an output also have an algorithm. So this is our rule or algorithm in here. So in traditional approach, if we want to solve this problem, like we want to find the Fahrenheit, uh, and we know the Celsius. So we already know this equation, and what we do, we just write a simple Python or any other language, a function like this. So you have a function with a value like an equation like f equal to c in 1.8 plus 32, and it returns a value f, and you are giving an input c into this function as a parameter. So we are just calling, whenever we call this function with a value, and this value will go to the c, and it will calculate the value of the Fahrenheit, and you will get an you know uh, output of Fahrenheit. So this is the traditional approach, and how the same problem can be work in a machine learning approach. So in a machine learning approach, actually, we have the data. The data I showed to you, like the 0, 8, 15, 22, 38, and we know some of the outputs. So we already know here, if you give 0, 32 is the output. If you give 8, 46.4 is the output, so and so. So we know these inputs and we know these outputs. So in here, what we do, we create a model, and we train the model using this data. We tell the model that this is the input and this is the corresponding output, and we train the model. So the model will learn from the data what we give, uh, the what we use to train the model. So finally, what we get is uh, a model which is trained by using the data that we already have. And then by using that model, we can ask the model, okay, so what will be the output if I give some random number 62? What will be my output? And so the model will give you, once uh, uh, you train the model, next you ask the model to predict what will be the value, like uh, a number which is not already in your data set. So you are asking a model with a input number which is not already you used for the training. So then the model will give you the exact result. It won't be 100% exact most of the time, but to some extent it will be close to the reality. Like it predicts the value. So what really happened during that prediction is, the model itself create a algorithm by its own, and then it's so in this case the model figure it out, okay, if the data is this and the output is this, then this algorithm or rule might be this. So model generate this rule. So that's how this same problem works in the machine learning world or the uh, AI world. So I can just show you these two scenarios in a working examples. Uh, so this is a notebook. We call this as a notebook or a collab notebook. So we can simply run the Python code, or this is mainly used for this AI machine learning purpose. People, whenever you want, you can just create new blocks and write your programming here, and you can easily execute each cell individually. So here what I done in this first block is actually
I don't think we
just
can see your screen. We can see just the presentation.
okay. You cannot see my screen. Okay, let me share. I will share it again. Can you see it now? uh, are you able to see my screen now, the Jupyter notebook?
Yes.
Yes, Salman, I can see it.
Okay, cool. So in this, uh, so this is what I just mentioned. This is a collab, Google Colab. We use this thing for for the machine learning or yeah, data science purpose. So this is just a function. I try to write a Python function, simple function. So with uh, parameters C, and I just want the value of f. So f equal to c into 1.8 plus 32. So I'm just saying to the program that okay, just return the value of f by calculating this function, and then I can just call any number. I'm just calling this function, and I'm here. If you call 0 and you run this function, you will get 32, because if c is 0, you will get f equal to 32. And if you give any number and if you run this, then you will get this f as an output 113. So this is a traditional approach, and the how we can do this in machine learning approach. So here is a program in machine learning where I just created the same um, uh, problem, but in the machine learning way. So can you see? Everyone can see this screen. I hope everyone can see this. Just hello. Uh, okay, cool. So before going to this, I just want to ask. Uh, for everyone, is it clear that the first thing what I explained about the traditional approach? Just type in the chat. Just type just okay or yes, whatever. So I don't know what you guys, whether you are understanding these things what I'm saying. That's why I'm asking. You can just type, okay, cool. So if anybody understand didn't get anything what I'm saying, just type in the you know uh, chat, and I will try to make it simple as possible. So here we are using a machine learning framework or library called TensorFlow, which is a well-known machine learning library which is developed by Google, and it's an open source library right now. So in this TensorFlow, um, there are a lot of, they already created a lot of machine learning models. So you can simply call these machine learning models. So before going deep into the technical side of this, I just want to show you the result, the comparison between the traditional approach and this approach. So here, just run this cell. You can just uh, execute the cell individually. So you can see it's just running right now. So once it's done, yeah, it's done. This is done, and I'm just running the second cell. So it's basically importing some, Python libraries like NumPy, which, which is mainly used for this, numerical purpose, and another one logging. So just executing this one. And here you can see I just defined the Celsius, which is our input. So uh, this is our input Celsius, and I'm just you know initialize with a NumPy array. So you can see our input values as -40, -10, 0, 8, 15, 22, 30. This is our input value. And we have our output Fahrenheit, so which is also an NumPy array with values -14, 40, 14, 32, 46. Yeah, so which is corresponding to, so -40, when you give -40, you have to get -40. So when -10, it's 40, it's 0, 32. So like that. The length of this both array should be, same, because you need to have a, if you have 5 input, you should have a 5 outputs, which is corresponding to that input. So, and then I'm just this is nothing about this machine learning. I'm just created a for loop, which is for showing in a good format. Like, so when you get results from this, it shows like -40 degrees Celsius is equal to -40 degree Fahrenheit, and -10 degrees Celsius is equal to 14 degree Fahrenheit, just for you know understanding better. So in this line or block of code, what we are going to do is we are just calling Keras. Keras is another machine learning library, which is a wrapper around the TensorFlow. So which makes things easier with so basically TensorFlow is a machine learning framework developed by Google, and Keras is an open source independent of the TensorFlow. Keras is developed by a group of developers, and which basically, if you have to write 20 lines of codes in TensorFlow, and then you use Keras, you can do the same with maybe 3 or 4 lines. So it's a wrapper around the TensorFlow. So I just created a layer in Keras. So just running this one, and then I'm just saving the model. It's a sequential model, so there's a lot of things like this. So you will get familiar with all these words when you go deeper into this machine learning, all sort of things. So I'm just saving the model as tf.keras.sequential. And yeah, it's also done. So next, uh, yeah, I'm just compiling this model. Okay. So what now I just trained this model. You see the fit model.fit. So whenever you see a fit function, if a fit object, so which means you are training. Here you created this model and serve this into this model. You just use a sequential Keras model from Keras and TensorFlow, and you here you declare the number of layers. So a lot of things you can mention when you create your own models. And then here what you do is you are just compiling the model, and then here you train the model. So while you training the model, you already mentioned uh, your inputs and your output. So now the machine know, I mean, that uh, whenever you give these inputs, you will get this output. So our model is trained right now. So you can see finished training model because I just printed this in here. Yeah. So this is something we can discuss later. This is this is a performance of metrics. So we can just look into this graph and analyze how our model performed with the training data. So this is not important right now, as of now. Now we created our model, and what we can do is we can just ask our model, okay, model, when I have input as 8, what will be the output? So you will get an output like this. So which won't be exactly same, but somewhat closer because it's a prediction. So when you give something else, yeah, so you will get a output, and I can just give it to 0. See, when you give the model 0, what you got, it's 31. It's close because when you remember the equation, it's f equal to 3 into 1.8 plus 32. So it's almost 32, 31.91. So our model is predicting really good. So that's why we are getting this number. So, and if you're wondering, so where is the algorithm in here? Where is the rule that model generated? So I can just show that in here. Okay, so these are some, variables that generated while once you train the model. So I'm just trying to print out this variable. So you can see the variable 1.7.9, and this, it is close to 1.8. And here you can see 31, which is close to 31.9.1, which is close to 32. So here in this slide, uh, you can see my slide, right? I'm just showing my slide right now, so you can just type if you are still seeing the collab notebook, or you're seeing my slide.
No, Sam, it's still on the notebook.
Still on the notebook. Okay, it's fine then. I'll do just okay, just type here. So this is our equation. $32. So this value is our output. So which we got as a prediction from our model, and this value that we ask the model to give the corresponding value for this 0. So which is our input, and the unknown here is these two variables, 1.8 and 32. We didn't tell model in any of this process that this is the equation, or this is what we want to find, or this is the variable we need. This variable is, or this function is generated by the model itself. So you can see this 1.8 is here, 1.779, which is almost 1.8, and the 32 is 31.91, which is almost 32. So this is how the model uh, gives us what algorithm. So you may be wondering that, okay, so why I need this machine learning if I know you can do this with the traditional approach. So the issue is like you can do simple, problems like this if you know the variables, and it's always preferred to do in the traditional approach if you can solve things with non-variables. But think about of situations like stock market predictions. So how many number of variables are there? It's it's a lot. It's a lot of variables, maybe thousands of or and thousands of variables depends upon a stock price. So we, even a human cannot make an equation out of that. So it's really tough to make such kind of uh, equations or algorithms. And in such cases, if you use machine learning, the only thing you have to do is you need to give the data like input and output, because from the history of trading, if you trace some history of trading, you can see that okay, uh, you have some trading values, and you can see these are these uh, inputs and these are the output of these kind of some kind of stocks. So if you give this to the system, uh, then it will try to predict what will be the uh, share value of a particular stock in a particular time or something like that. But still, prediction of stock price is a bit complicated one. It's a different kind of data. Like even in the machine learning, you won't get an accurate value. But then you can think about situations like some problems, the spam filters in the email. So yeah, so when you think about the spam filter, uh, so you can think like there are subjects in the email, there are body in the email, and email itself. So you can categorize whether an email is a spam or not, like just saying some kind of words like a common word like just letters and numerics and letters together, like for you kind of thing. So if you see some kind of uh, unusual characters or sentences, so you can in a traditional approach, what you do is you just write your rules, like if you find this kind of words, specific words in an email, it might be it will be a um, spam. And so whenever you get an email, your machine will check whether this thing is spam or not spam. But in machine learning, you can do the same, but in the traditional approach, things will change. Like you cannot trace every variables in even in a spam filter. So in machine learning, well, you don't have to make rules for that. Only thing you have to do is just saying, just giving the training the model with the some data, like okay, you have some set of emails and you're just giving these emails and you're saying that's your input, and you're saying okay, this is my input and there are some output related to that, like this email is a spam because you already labeled this uh, is a spam email. So you are saying the output labels as it's a spam and it's not a spam, it's a spam, it's not a spam, like that. And you train your machine learning, you create a model and you train your model using this data, and then you will get a model which is trained by this kind of data. Then you use this model to predict the future emails. So when you get a new email, you can just use this model and input this new email into this model, and you ask your model whether it's spam or not. So based on the trained with the previous data, your model will predict, okay, this is a spam or this is not a spam. So yeah, so like that. So this is the main differentiation between the traditional approach. and the machine learning approach or the AI approach, deep learning approach. So you can even think about more complex situations like let's say the voice recognition, so or natural language processing. So voice recognition is you need to, there are a lot of variables, so you cannot track of your variables, and you don't even tell your systems like how to make predict make rules uh, based on some kind of voice or some kind of languages. It is really difficult. So in those cases you use machine learning, you will get a really good results. So yeah, so I think so that's all about this. So I just want to ask, if you have any questions, just ask guys. I can give you the answers. If you have any doubts, you can type in the chat. If you didn't understand something that I mentioned here today, you can just ask about these things. One second, I just want to plug my laptop.
Yeah,
Meanwhile, you
guys,
can.
feel free to ask any questions. You can open your mic, you can put them in the chat box. I also put a link for a form where you can, if you want, you can fill it to receive the slides and the recording of the session. You can just fill it and you'll receive everything by today. And I'll also put my email in case you have any questions. You can also email me as well. For now, if you have any questions for Salman, like go ahead, please ask something.
Hi, YA. Yeah, sure. Please feel free to ask, guys.
Yes, Mohammed, feel free to register in the form. You will receive the recording and the slides as well.
And so, what do you think, guys? Like, how did you understand this concept? Like, okay, how it's different from spam prediction on our email? So, you want? Okay, I will explain it again. So, in a if you want to make a spam prediction model or something in a traditional approach, you have to know all the details, like for example, you say I'll just type for you, like if you see a for you in your email, some in the subject line or something like that, it's an unusual email, it might be a spam. So you are saying machine like, okay, if you see for you or something else, like what you can say, like uh, yeah, so what we usually see in the spam emails. So you can say, you already know that it's a spam, so you make a rule like if you find this in an email, just classify it as a spam. But the problem with the traditional approach is that even if you are getting an email which is not actually a spam, but uh, it's contains something like the words like for you itself, and it's not a spam, your program will classify it as a spam email. And also you can't track all the related characters or words for mentioning it as a spam. So and also these spammers are always changing their rule book. So they change new strategies, so they use new words. Sometimes even we cannot identify which is a spam or in the first look. So in those cases, it is really tough for a traditional programming approach to make a solution for these kind of problems. So instead, if you use machine learning, what really happened, you already know that you have a set of data, so which contains inputs as these emails and output as the which is a spam or a not spam. That's the output. So you are saying, okay, you have a data set and you are saying this email is a spam and this is email is not a spam, and you trained your machine learning model. In machine learning approach, you train your machine learning model with this data set, and you get a model which is trained, and then you use this trained model uh, to predict whether a new email which is coming to you is a spam or not a spam. So our model really under the hood, it's creating a algorithm by its own. So and there are a lot of, it may not be 100% right, or it will not be 100% right anyway. It will be like some, if it's your model is really doing good, it's kind of, some 90 something percentage, 90 plus percentage, you will get a good model accuracy. But if your model is performing very low, and there are some situations, if you create a model, your model won't give you best results. So, and there are a lot of things in machine learning. You can measure the performance of your model always. So there are a lot of techniques in the machine learning. So you can do those kind of techniques, and you can just always optimize your model for a better performance. So once you got a better performing model, you can use this model for predicting any kind of new emails, and you will get a better results, and you don't have to change the rules accordingly when the spammers are changing. You don't need to change the rule because the rule is already created by model itself, not by you. So the only thing you need to do is optimize the model initially, and also there are a lot of options like fine tuning the model. Yeah, so I think that makes sense. Or is it clear now? Bhaiya? Uh, thank you. Okay. So if anyone has any kind of doubt, you can just type here. So any of the concepts we discussed today, if you have any doubt, or you want to know more about, do you have any other doubts in your mind about machine learning? What is it like? Something like that. So just type here what you think. It's okay. You can type here anything. Like if it's uh, any kind of questions, it's won't be related to directly any doubts, even some stupid doubts. It's okay. Fine. Come on, guys. Just type something.
It's okay, Sama. I think everyone wants to go and have lunch now.
Okay.
Yeah, I have a question here. Yeah.
How many time in a real world practice we have to make a new algorithm model? Uh, so in real world, what we actually do is, like I show you in the example in the collab notebook, uh, we always use models which from the libraries like TensorFlow, PyTorch. Uh, yeah, exactly. We are using the existing model. We don't have to go and create this complicated mathematical function for a model, because it's already created and people are creating better model every day. So as a data scientist or machine learning practitioner, what we usually do is we choose the best one, and we choose, and a lot of hyperparameters you can adjust in a machine learning or deep learning world. So you will adjust those things and you will figure it out. Okay, this is working or this is not working, and you will try the other one. So it's all about uh, choosing some existing performing models. Nobody is going to create model by themselves, and all of these models, when you go to internet and you go for the specific website, you can see the documentation, and they will explain really well like how their model works and how you can use that model as a user manual. And that's what you know machine learning practitioners do. But for uh, for the knowledge, you need to know which one you should choose, and you need to know the concept really well. If you want to make this existing model and you want to you know uh, just fine tune your models and do all sort of these things. You don't need actually a PhD. I don't think so, because you don't need a master skills of stats. But knowing statistics, even if you don't know statistics, you only know a little bit of statistics. It's okay. You can still do all these kind of things. But if you know all these things, like if you understand what's really happening uh, under the hood, like the statistics part or the mathematical part, it will be more good for your future journey. Like you can do things better, you can optimize things faster, and so it will always good to know much deeper. But still same time, you don't have to know all these things for doing some machine learning problems to solve, of course. But it's always good to know. It depends like how you want to, which even AI and machine learning is a broader, very broader area. I can show one more slide from this thing if you want. So uh, so you can see this one. Hope you're able to see this. So this is basically about AI, machine learning, and deep learning. Everything comes together. So AI, deep learning is a concept subset of machine learning, and machine learning, NLP, and deep learning all are subsets of artificial intelligence. So it's up to you. Like NLP is all out of it's all related to the natural language. And if you want to uh, do this sentiment analysis and even uh, spam filters, not spam filters, you don't really need NLP. But in some case, if you want a chatbot, voice recognition, also related to NLP. And in NLP again, we are using deep learning, machine learning. So, and for this image recognition sort of things, we mostly use the deep learning only, not the NLP part. So it's a broader and wider area. So it's up to you what to learn, or which one you want, and where you want to go deep. And there is a lot of opportunities and space for you to choose and decide where you want to go deep. Yeah. So yeah. Any more questions? Oh, thank you, man. Thank you.
Perfect. Thank you so much, Sama. That was really insightful. I posted the link for the form again, guys, if you want to receive the recording and the slides. And also, if you want Salman, you can put in your email if you want. They have any questions also, and I also put in my email. If you have anything, just let me know, guys.
Okay, so all right, thank you everyone for being here. Yeah.
You're most welcome. I hope you guys enjoyed it. Thank you, Salman, again, and have a great day, everyone.